So for all lines, if we're doing domain and range, I know this question says range, but I'm going to give us the details for all domain and range of all lines. Notice this is a line. So for all lines that have a slope, so in other words, m is not 0 and m is not undefined. Those are special cases. I'll talk about those in just a second. But for all other lines, all lines that have a slope at all, if slope equals something, the domain, you don't even have to look past the fact that it's a line and it has a slope that's not 0. The domain will always be all real numbers, which you could write as negative infinity, comma, infinity, like that. The cool R means all real numbers, negative infinity to positive infinity. The range will always be all real numbers, which again is negative infinity to positive infinity. So this is always. Like, you don't even have to do the work. You don't have to be scared. This is the answer as long as you have slope that's not 0. And it's not undefined also. But if it's undefined, it doesn't technically have slope, so that's another thing. So let's talk about those other ones, the special cases. They're a little bit weird. So if you have m equal to 0, that would be a slope of 0. A slope of 0 would be a horizontal line. That's a terrible horizontal line, but you get the point. So this would be if m was 0 here. If that's the case, every time you have a horizontal line, so it's a horizontal line, immediately you can say your domain is all real numbers, but the range is not all real numbers. The range is special. The range will just be y equals whatever the y value is that they gave you. In this case, it's 7. So I put 7. But it's always some y value, whatever number it hits the y-axis at, that's the range. It's the only value of y that we have anywhere on that horizontal line. That's how horizontal line goes. You might have some of those roll through your example problems. And then if m is undefined, this means you have a vertical line. If you have a vertical line, it's actually an x equals equation, some number. I'm going to draw one right over here going through, let's say, -7. Okay, so that would be a vertical line. That's x equals -7. If you have a vertical line, it doesn't have slope. Its slope is undefined. Okay, -7 is my number that I'm talking about there. Then what you do is your range is all real numbers. The range is all real numbers, but the domain is not. The domain is just whatever this is. It's x equals whatever your number is. And in my case, I had this set in -7. That works every time for any lines. Those are the rules. So have that ready to go anytime you have a line. Quickly, right there is your answers. All right, so this one being a polynomial, there's only 2 types of domain and range for polynomials. The ones that look like this one, this is an odd degree. Now we're going to spend a ton of time talking about polynomials as they're a standalone, so I'll get into that in just a second. But for even degree, they look different. So we'll deal with those in just a second also. The odd degree all behave just like this one for domain and range. The end behavior, if you can draw from one hand to the next like something that looks like a line like I just drew there, it behaves like a line without slope. With a slope, I meant to say. So it's like a line with a slope. So just like the last example I showed, your answer is all real numbers for the domain and the range. Immediately populates, that's the answer. Now, even degree graphs don't look like this one because their ends will act like a parabola, either a sad face parabola or a happy face parabola, and they're different. So on these ones, Whenever you get an even degree polynomial, you're going to have the domain is all real numbers, but the range is going to be different. The range is you have two options. It's either negative infinity to some y height, and then it'll be a bracket on the y height, or it'll be some y height that it starts with on up to infinity. Those are the only options. We don't know what the y height is. That's case specific, but when you're looking at the graph, you'll be able to tell that y value because it'll be a highest or lowest point. So anytime it looks like if you can take the arrows and draw a line through them, sorry, my line took off sideways again. If you can make it look like a line, then the answer is the same numbers. And then if it's a parabola like, then it's one of those other two options. All exponential functions. We're going to talk about domain and range. So this is an exponential function. How I know that is that you can see it's kind of tapering off sideways right there. It looks like it starts touching 7 and then just it heads on along that line. It actually is not touching that height of 7. If you zoomed in a billion times, it would separate and actually be a little space there. So all exponential functions have a horizontal asymptote. This is a horizontal asymptote. And what that is it's a line that the graph approaches as x goes infinitely large or positive, negative, infinity, infinitely small. You'll get a y equals some number. In this case, it's 7. That's what this y height is that this graph is approaching. So you can imagine that there's an invisible line that we can put. You'll see them on different graphs with dotted lines, and that's just showing you where it is. All exponential graphs have that. That is your y barrier for range. So here's the deal with exponential functions. All exponential functions they all have a domain of all real numbers. And again, you can write negative infinity to positive infinity if you like. I like the cool R when I can use it. The range is always an issue though. So the domain is always this. You can count on it. The range is different. The range depends on which type it is. There are the ones that look like this one. And there's two types. It can go up and sideways like so, or it can go from sideways and then head down from there. Both of these have a horizontal asymptote like this one. So if this is your case, then the range is going to be from down here at negative infinity up to your horizontal asymptote, but not touching it. So you'll just write negative infinity, parenthesis, up to whatever y value your horizontal asymptote is. So I'll write y equals HA, parentheses. Now this is a number, okay? Please don't write y equals HA as your solution. It's a number, so negative infinity to that number, parentheses on both. Every time all exponential functions that behave like these two, that's the result you're gonna get. Okay, now I'm going to draw the other type that doesn't look like this graph. A standard exponential growth would look like this, or an exponential decay graph that looks like this. Both of these graphs, that blue one didn't taper off as far as I wanted it to. They both have a horizontal asymptote at the bottom. This is your HA. So these ones, their range is always going to be the HA goes first as the lowest value, and then we go up from there. So it's y equals your HA, comma, and then it's going to go up forever. Both of these go up forever to infinity, like that. Let's see if I can't separate these a little bit better. Some purple. So these are your two options for range with exponential graphs. Now for rational graphs, anytime you get one of these functions, It's a total situational result, but it's always the domain and range they both are going to be all real numbers, comma, some excluded values. Always excluded values. There might not be an excluded value, but you always have to be concerned for excluded values. So when it's a domain, you're going to exclude by saying, so domain at the top, you're going to say X can't be, and then you'll have a list. And then for range, you'll say all real numbers, and then you'll say Y can't be, and then you'll have a list of numbers. You're going to have to look at the graph. We have a whole unit on rational functions, so there's a whole lot to it. But looking just at this graph, I hope that you can see there's a couple of excluded values here. Right here, you'll notice that this graph right along that -4, it doesn't actually touch it. It gets really close and points at it, but it doesn't touch it. So what that is that's actually my Y domain restriction, or Y range restriction. So my range, in this case, on this problem, because of this line right here, I say all real numbers, comma, Y can't equal, for this graph, -4. That would be my range. Now, if I had to write that in an interval, it'd be really annoying, but I would be -infinity, comma, -4, and then you use parentheses on both, union -4 to infinity. And what that does by putting the parentheses on -4 on both sides here, it causes that to be a blip in your range. The easiest way is just to exclude it and just say, why can't be -4? It means everything else is good. And so we don't typically write it this way. I don't need you guys to write it this way for me. It's a really big hassle. I just want this one. It's a lot more convenient. And then the domain, alternatively, would be a vertical asymptote. And right here, you can see that the arrows, I kind of missed the box there a little bit. I'm kind of on it, are right there at 2. Close that. Right here, you see this vertical line is 2. That's X equals 2. So what we do is we say X equals 2 is an issue. So what we do is we cross out the equal sign. So our domain is all real numbers, comma, X can't be 2 is what we would write for these rational type of functions. So it's always all real numbers, comma, X can't be something, or Y can't be something. So the other way we could have written this, by the way, for the domain is -infinity, comma, 2, parenthesis, union 2 again, comma, infinity. And again, that's the really obnoxious way to write it, I think, just because it's annoying, but it does work. This one, I think, is much more convenient, but either way works. All right, you'll notice that this is a parabola, and it behaves just like the notes I gave you for how polynomials behave when they're even degrees. And I said that the domain is always all real numbers. So we can go ahead and say that, all real numbers. It didn't ask for that, though, the problem specifically, but you will see that. The range, because it's going down, it starts at -infinity for a Y height, and then it goes up and tops out, but not including the 5 here is what the graph does. Or sorry, but including. I said not including. I meant it does touch it here. So we're going to say the range is starting the lowest to highest, -infinity, comma, 5, and then you put a bracket on the 5. A lot of students reverse that, and they say 5 to -infinity, but you always have to go lowest to highest to get the right result. So again, that's just a specific example of how the even degree polynomials behave. Looking at an absolute value graph, they behave just like the happy face parabolas or even degree polynomials that are moving up. You'll notice that the arrows on both of these are going up. So the range, the highest it goes is infinity. The lowest it goes is it does actually touch the bottom here at 4. And just like those even degree polynomials, the domain is always all real numbers. That's not what this particular problem asks for, but that's all right. So the domain would be all real numbers. The range, and always is for these absolute value. This is an absolute value of x graph. Anytime, well, it's shifted. That's not actually what the equation is. But anyway, the range, the lowest is 4, bracket, comma, infinity. So it's the lowest y value to the highest y value. You can see the lowest value is 4, and it goes up to infinity. This square root graph is just a segment of, there's actually, it's kind of like a sideways parabola. If you imagine it would go like that, but that's not what this graph is. We actually split it. This is technically the positive version of the square root function, and this is the negative version of the square root function, because the only part we were given was the negative part. We don't think about the top part because we don't graph both at the same time because it wouldn't pass the vertical line test. It wouldn't be a function. So anyway, all that to say, this equation right here, its domain starts, it's restricted at this spot right here, and then it goes on to infinity. The range is also restricted by here to infinity. All square root functions are restricted in the domain and in the range. So square root functions, they are always restricted. The domain is going to be some x value, comma, infinity, and the range is going to be some y value, comma, infinity. Or that would be if it was a positive going up one like that. Or when you're going in this one here, if you're going, you hit negative infinity first is what you say, comma, whatever the y value is with a bracket. It's got to go lowest to high. So fix and put that in your notes. So lowest value here on this graph would be negative infinity because it's going down. I know it's going off to the side, but it is going down for forever. So it's negative infinity, comma, the highest height on this one is negative 3. So bracket the negative 3, and then parenthesis on the negative infinity, and the domain, the furthest left was 5, comma, infinity.